Hi, welcome to my video on Solve Similarity Word Problems. Solve Similarity Word Problems. Let's do some examples and then you can work some out if you wish. A tree casts a shadow 10 feet long. At the same time, a person 6.3 feet tall casts a shadow of 2.1 feet tall. How tall is the tree? Okay, let's draw a diagram of the tree casting a shadow, and let's draw a diagram of the person casting a shadow at the same time. And the tree is perpendicular to the ground, and the tree casts a shadow of 10 feet, and the person casts a shadow of 2.1 feet, and the person is 6.3 tall. We have to find how high or tall the tree is. So let's let x be the height of the tree. And being similar triangles, notice that the angles are equal. These are right angles, and the tree and the shadow, the angle with the ground is the same, and this angle here is the same. So the triangles are similar. So let's do x is to the height of the tree, x is to the height of the person, as the length of the shadow of the tree is to the shadow of the person, keeping everything corresponding parts. And cross multiply 2.1x equals 10 times 6.3, and 2.1x 10 times 6.3 is 63. Divide by 2.1, x equals, that cancels, and 21 into that goes 30. Take your calculator out and do 63 division 2.1, or if you wish, we can go just try it with a pencil. 2.1 of 63, the decimal 63 is to the right, so we move this one place, move the decimal here one place, move the decimal up. So 21 into 63 goes 3, 3 ones are 3, 2 threes are 6, subtract, you get a 0, bring down this 0, 21 into 0 is 0. So you can see you get an answer of 30 feet. So the length, the height of the tree, or how tall the tree is 30 feet. Let's do another one. A road rises 3 meters for every 100 meters of run. Find the rise of the road if the run is 0.6 kilometers. Again, we have a road that rises. Let's do it this way. We have a road that rises. Okay, this is the road. Road rises 3 meters for every 100 meters of run. So notice this is a right angle. The rise of the road and the run are perpendicular to each other. This is how the slope of the road. Find the rise of the road for a run of, so we have a longer distance, and what's the rise in this case? So we have a right angle. But notice now this is meters, and this is kilometers. So the first thing we have to do is take 0.06 kilometers and convert it to meters. So 0.06 kilometers we multiply by, there's 1,000 meters in 1 kilometer. So the kilometers cancels out. 1,000 times 0.6 is 600 meters. So the rise, find a rise. So the rise is x for a run of 0.06 kilometers, which is 60 meters. We have to keep the units the same. So notice this is the normal, rise of 3 for a run of 100. Now we got a run of 600. What's the rise? Well, 3 goes with the x. So the rise with a rise and the run of 100 with the 600 to keep the proportions are equal. The triangles are similar. So we cross multiply. We can multiply these two first, or these two, makes no difference. Well, since the unknown is here, I can go 100 times x is 3 times 600. That's the same as if I had gone 3 times 600 equals 100 times x, either or. But because I have one unknown, then I'm going to multiply this one first and this one second. That keeps the x on the left side. So 100x equals 1800 divided by 100. It cancels to give me x. Zeros cancel to give me 18. And you can see that this is 6 times longer in length than this. So 3 times 6 makes 18. I could have also solved it this way, but this is okay. And so the rise is 18 meters. Let's continue with some more word problems. Again, we're forming similar triangles, and their ratios, corresponding ratios, are equal. Practice means pause the video and work out the problem as we have it. Let's see. Do one at a time. A pole 15 yards high casts a 10-yard shadow. At the same time, a person 2 yards tall casts what length of a shadow? Again, the same idea that we did just then. So we have a pole, and the pole casts a shadow, so the shadow is along the ground, and we form a right triangle. And so a pole is 15 yards high or tall, and it casts a shadow of 10, and there's a right angle, so we're assuming that the pole is perpendicular to the ground. And a person, let's draw a smaller diagram. So this is the person, which is 2 yards tall, is casting what length of shadow? Remember, the shadow is along the ground. So what we have is 15 goes with 2, as 10 goes with x. So the height of the shadows of the pole, so the height of the pole to the height of the person, the shadow of the pole to the shadow of the person. Cross multiply. 15x equals 2 times 10. 15x equals 20. We divide by 15, and that gives us x equals 20 divided by 5 is a 4 over 3. 4, so we could leave it as 4 over 3 or 1 1/3. And we're dealing with yards. So the length of the shadow of the person is 1 1/3 yards. Again, notice all problems here are related to similar triangles, even though we're doing a similarity. But you can see corresponding parts are equal. Another one, a jet rises 25 meters for every 100 meters the jet travels forward. If the jet is horizontally 900 meters from the takeoff point, find the height of the jet in the air. Okay, let me draw a little diagram here. Now pretend this is a jet taking off on a runway. So here's the jet going up on the runway. Jet is taking off right here and flying in the air. And it says, there's several parts to this, we got to be careful. This is the height of the jet here. This is the horizontal distance along the ground that the jet has traveled. And this is the distance that the jet has traveled in the air. So be careful. The horizontal distance is this on the ground. As the jet is flying up into the air, the distance that it climbs or the distance that it travels. So be careful. A jet rises 25 meters for every 100. So it rises 25 for every 100 meters the jet travels forward. So I'm assuming that at the jet travels forward, then it rises 25. It's not the distance that it climbs in the air, so be careful. If the jet is horizontally 900 meters from the point of takeoff, so what happens? Let's draw a bigger diagram now. So here it is. Here's the jet. So the jet is horizontally 900 meters from the point of takeoff. So notice it is 900 meters. So there's the point of takeoff, and there's 900 meters from the point of takeoff horizontally. So this is, and we want to find the height of the jet, which is x. So again, we have 25 over x is 100 over 900. And multiply, again I want to multiply this first. So I get 100x equals 25 times 900. And that gives me 100x. And 25 times 900 is 22500. You use your calculator. Divide by 100. It cancels. It gives me 1x. And that gives me, the zeros cancel, 225 meters. That's the height of the plane. Again, be careful. This is the horizontal distance on the ground. This is the distance that the plane travels in the air. Be careful. Number 3 is a common problem. Pretend you have this problem and you have a river, but you want to find the length of the width of the river across the river, but you can't get over to, let's say you're on this side of the river and you can't get over to here. So what you can do is make up a diagram like I have down here. You can leave P and go to R, and that's 48 feet. So we leave here and go 48 feet, and then leave here and go 6 feet. Now the reason I did 48 and then 6, because notice I did 6 eighths or 48. So I'm making this distance, these distances here, 8 times bigger than the distances in these triangles. So if you leave here and walk 48 feet, and you leave here and walk 6 feet, now you walk out here until the line of sight passes through this point and also goes through Q. So this line of sight here is from B to here, and whatever that distance you measure off, so let's say that was 4 feet that you, so if you went 48, then you went 6 and went perpendicular to that 4 feet out here, and when you stopped, you have a line of sight that moves right through here. That means you have a right angle here and a right angle here. This angle equals this angle. We have similar triangles because 2 pairs of angles are equal. That means the distance to cross the river, which is PQ, is going to be the x that we're going to find. And we have set up similar triangles. So therefore, if you set up similar triangles, notice that this side, x across the river, is going to go with 4, and the 48 is going to go with the 6. You could do ratios and set them all up and do similar triangles, but you notice that these 2 right angles are equal, these angles are equal, and this angle is equal. So this side is going to go with this side, and this side right here is going to go with this one. And work that out, you get 6x equals 4 times 48. 6x, 4 times 48 is 192. And you divide by 6, and we get x equals 32. 32 feet is the distance across the river. And that can be set up all on one side by, again, what you're setting up is similar triangles. And we have another problem to do. Again, pause the video and see if you can work this one out. But this one is, notice I got extra marked on it. Extra means there's more thinking going on, more than just similar triangles. A ski lift rises 30 meters for a horizontal distance of 40 meters. The lift rises at a rate of 6 kilometers an hour for 1.5 minutes. Find the distance the lift travels. So if you think about it, you have a lift, there's the ground. So the lift is going up the hill like that, similar to the plane rising. So once you get on the lift, you start to rise. The lift comes in and picks you up, and you rise up into the air. And what we have here is the ski lift rises 30 meters. That's the rise, for a horizontal distance of 40. So as you travel 40 along the ground, it rises 30. Now, but it has a rate. Notice it has a rate right here. The rate R is 6 kilometers per hour, and we have a time of 1.5 minutes. So this rate and time, this is in minutes and this is in kilometers per hour. But also notice that you have a rise and a run, in a sense, of meters. So kilometers per hour got to be changed to meters per minute in order to multiply by this time. So if you take the rate of 6 kilometers per hour and you multiply it by, now we want to convert the kilometers to meters. So 1 kilometer is 1,000 meters, and that's a kilometer. And we have time, so we have 1 hour is 60 minutes. So notice if the kilometers cancels out and the hour on the bottom cancels out. So the only unit we have left now is meters per minute. So meters and minutes. So 6 cancels into 60 10 times. 10 cancels into 1,000 to give you 100. So what we have right now, the conversion is 100 meters per minute. So distance equals rate times time. So the rate is 100 meters per minute, and the time is 1.5 minutes. So the minutes cancels, and we get 100 times 1.5, so that's 150 meters. So that's the distance. So what we have here now, if we redraw the diagram, so that's a 40, and that's a 30. So now we have that it rises at a rate. So it's rising at a rate of 150. So what happens? It's rising 150 feet at that time. So that's the rise. 150 meters. We want to find the distance the lift travels. The distance, the horizontal distance that it travels is x. Travels along. So we have 300 over 150 is 40, and x. So the height rise to each and the run to each. So 30x So notice this is x. So that's 40 times 150. So 30x is 40 times that is 006 divided by 30, and I get x equals 0 cancels, and I get 200. But notice this x that we traveled here, that's the horizontal distance, because this is the rise and the run. So based on this, if this is the rise, x is the run, it fits in this triangle. but the distance that the plane traveled, or sorry, actually plane and time, but the skier traveled is this. How far did the lift travel? So what we have, let's put 200 in here. We got a right angle. So this distance is for what we call Pythagorean. C squared is A squared plus B squared. Where, if you think about a right triangle, we have a C, an A, and a B. So C squared equals A squared, B squared. C is the hypotenuse right here. So we have the distance squared is 200 squared plus 150. Let's put brackets around those. And 200 squared is 40000. Use your calculator. 150 squared is 22500. And when you add those, you get 62500. So D squared is 62,500. D is the square root of 62500. So D is square root of 625 is 25, and 2 zeros gives you 1 0, so it's 250. So 250 meters. Again, notice the similar triangles is the height to the horizontal distance. So you have to work out the horizontal distance first by doing the proportion. That gives you 200. And then the distance that the lift travels is the D. So again, the problem is a little tiny bit different, a little bit rougher. And if you do understand, everything is great. But just look at this problem. Look at the power, or the math, I should say, that's in this problem. Had ratios, you had to convert to get to the same unit. Then you had to do similarity to get the same horizontal distance. Then you had to do Pythagorean to get the distance that the lift traveled. Again, this is the horizontal distance, and this is the distance that the lift travels. So there's two distances that the lift travels. So be careful of what you're given when you have a question like this. And if you like my video, click the like button, click the subscribe button, click the notification bell. More videos coming. Visit my math website, www.mathfullyexplained.com, to find more information about me, videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.